Hey kids, we are going to go ahead and start chapter 4, which starts with triangles and just classifying triangles, and we will build up to doing some proofs, your favorite things. I like triangle proofs, they're my favorite kind of proofs, to be honest with you. The first thing, this is probably all review, or it should at least all be review for you, back to grade school even. So listen as you need to, ask questions as you need to, and we'll go from there. So the very first thing that we're going to look at is just classifying triangles. And the first thing is we're going to classify them by their angles. So if a triangle has 3 acute angles, we call that an acute triangle. If it has 1 obtuse angle, we call that an obtuse triangle. And I'm just going to write obtuse and put a triangle. If it has a right angle, we call it a right triangle. And finally, if there are 3 congruent angles, if all 3 angles are the same, that means that it is an equiangular triangle. So all 3 are the same. And if you recall from, and that should be together, that's all one word, from previous knowledge, that all 3 angles in a triangle add to 180 degrees. So if you do 180 divided by 3, if every single angle in a triangle is 60 degrees, then it is equiangular. So we're going to go ahead and use the diagram to classify each triangle by its angles. The first one is triangle CDE. So here's C, D, E. You can see that this has a right angle right there, so we know that triangle CDE is a right triangle. Feel free to pause the video as we go. The next triangle is triangle BCE. BCE, you can tell that this angle right here is an obtuse angle, so we are going to call this an obtuse triangle. The third triangle for number 3 is triangle ABE. ABE is right here. And by these markings right here, I know that all 3 of those angles are the exact same. So we call that an equiangular triangle. The fourth triangle that we're going to look at is triangle BDE. Triangle B is right here. D is this big guy right here, and E is right there. So you can see we know that angle right there is 90. This angle right here is bigger than 90, so we know that this is an obtuse triangle. And finally, we have triangle CFE. C is right here, E is right here, F is right here. I know that this is smaller than 90, so I know that this is an acute triangle. The next thing that we're going to categorize triangles by are their sides. If there are 3 congruent sides, we call that equilateral. If we have 2 sides that are marked congruent, we call that isosceles. Oh, I just spelled that wrong. It should be ISOSCELES. So ISOSCELES. Sorry about that. And then if there are no congruent sides, nothing is the same, we call that scalene. So we want to go ahead and look at the next examples and try to figure out what those 3 triangles are. The first one is JKM. JKM. I know that those are all different sides, so I'm going to call this scalene. You can never assume that 2 sides are congruent. They have to be marked as congruent, or you have to be told that they are congruent. Triangle KLN. K, L, N. You can see that we have these sides marked the same, so we are going to call this an isosceles triangle. And in number 8, we have triangle J, K, N. And you can see that these sides are all marked with 1 mark, which means they are all congruent, which means we have an equilateral triangle. I'm going to go ahead and pause the video on my end. I want you to go ahead and do numbers 9 through 14. Notice that it says by its angles and sides, and then come back and check. Okay, so as you can see, I went ahead and did the bottom. Go ahead and check your answers. All right, I'm going to go ahead and flip that to the back. If you need more time, go ahead and pause the video. On the back, it talks about classifying triangles and says that they're in the coordinate plane. So basically, you are going to be looking at something in the coordinate plane. So if we have an XY axis and we plotted, those points, we made a triangle. What it's going to ask you to do is it's going to ask you to classify that triangle and find the measures of those sides and classify it right now just by the sides. At one point, or at some point this chapter, we will be able to classify by angles as well, but right now we're just going to classify it by its sides. So the first one here that we're looking at gives us triangle JKL with J at -7, -7, K at -9, 1, and L at -1, -1. Just to give you an example, I went ahead and graphed what that would look like with triangle JKL. And basically all we're going to do is use that distance formula that we've been using so often to go ahead and find the length of those. Remember, the distance formula is D equals the square root of X minus, I'm going to write it on here for you. Distance equals the square root of X minus X squared plus Y minus Y squared. So that's what we're going to use. So we're going to go ahead, I'm going to go ahead and pause it while you set those up. Come back and check them as you set them up. Actually, real quick before I do that, because you have a triangle and you're doing 3 sides, I would highly recommend going ahead and saying, okay, I'm going to do JK first and JK and do what is that distance equal to? What does JK actually equal? And do that one. And then I'm going to say, okay, the other side that I need is what? If I'm thinking about the triangle, I have JK, KL, and JL. So I'm going to do KL next and say, okay, KL is equal to, and then my last one is JL, and do JL is equal to. So I would make sure that you separate those out so you know exactly what you're doing. Okay, so as you can see, I went ahead and found the distances, and because I just need to compare their sides, I really don't need to find the decimal form. If you want to, you can, but there really isn't a need to, just because I can look at this and say, okay, I know without doing anything else that these two are the same. I know that they're equal, they're congruent, that JK equals KL, JK equals KL, and this one is not equal. So when I have 2 equal sides, what do I classify that as? Is isosceles. Go ahead and do the next one and then come back and get the answer. Okay, so you can see that I have found the length of side JK. JK I found to be the square root of 41, KL I found to be the square root of 85, and JL is the square root of 130. Because they are 3 different, that means that you have 3 non-congruent sides, non-equal sides, so that means that this is a scalene triangle. Moving on to solving for sides with algebra, you may see pictures that have the triangle in it. I think they're a little bit harder when you have to read and figure out what the triangle is yourself. You may want to draw a picture of that triangle just to get an idea of what that triangle would look like. So as you could see, you could have something that looks like that, that it tells you that it's equilateral triangle and they give you the triangle. I think these are a little bit more challenging. So if we look at the first one, it says if triangle PQR is an equilateral triangle, equilateral tells me what? That all the sides are the same. So all the sides are the same, and it tells us that it's triangle PQR. So before I even go any farther, if it helps you to do so, you could go ahead and draw triangle PQR, PQR, and I know that it's equilateral, so I know that all sides are the same. It then tells you that PQ is 18x plus 1. It tells you that QR is 24x minus 17, 24x minus 17, and PR is 15x plus 10. We are to find x in the measure of each side. So the thing is that this problem gives you more information than you actually need, because I just have to solve for x. So really, since I know all three of these sides are the same, I just need to pick two of those sides, set them equal to each other, and solve. So the two that I'm going to pick are the PQ. I know that PQ equals PR. And like I said, you could pick any of them. And I know that that means that 18x plus 1 is equal to PR, which is 15x plus 10. So I'm going to go ahead and solve, subtracting my 15x on both sides. So 3x plus 1 is equal to 10. Subtract your 1 on both sides. 3x equals 9. Divide by 3, x equals 3. So that's fine and well that we know x equals 3, but now the other part of that says that we need to actually find the measure of each side. I don't need to plug into all of them. I need to plug into one of them because we know that they're all the same. So I'm going to use this PR. PR is equal to 15x, and x is 3, so 15 times 3 plus 10. So I know that PR is equal to 55, which means that QR is equal to 55, which means that PQ is equal to 55. So all three of those sides are 55. Let's go ahead and read through the next one. Number 7 on here, and I know the numbers are off, but it is what it is. This says that triangle STU is an equilateral triangle, so it also tells us that all the sides are the same. So STU, and they're all the same. And it tells us that ST is 1 less than twice x. 1 less than twice x. So 2 times x minus 1. SU, it tells us, SU is 37 less than 5 times x. 5x, and it's 37 less than that. And TU is 11 more than x. X, and it's 11 more than x. You're supposed to find x and find the measure of each side. So what we want to do is go ahead and set those, pick two of them and set them equal to each other. 2x minus 1 equals x plus 11. We're going to solve that. X minus 1 equals 12. X equals 13. And then you would plug those in. 2 times 13 minus 1 gives us 25. So that means ST, SU, and TU equal 25. I want you to go ahead and read through number 8 and then come back and check out what work I have since we only have a few seconds left. Okay, so very quickly, highlights of this problem. It's an isosceles triangle. Notice it tells you MK is congruent to ML. When I drew my triangle, M is down here, so MK and ML are these two. I labeled my sides. I took the two sides, the MK and the